8.7 is dilations. Now, with dilations, there's a handful of stuff going on there in the first couple paragraphs. Okay, the first thing we need to talk about is dilation, and it doesn't really tell you this, I mean a little bit, but a dilation is the only type of transformation that we have that is not an isometry. What does it mean to be an isometry? Travis? Okay, it preserves size and shape then, right? Which is what you said, just in different words. Okay, it preserves size and shape. Okay, with a dilation, it does not preserve size. It preserves shape, but not size. Okay, so keep that in mind. They're going to be different sizes. Okay, a dilation is just like, the best way to think about it is like a magnifying glass. Okay, you're making something really small bigger so you can see it. Okay, that'd be the best example. Now, with dilations, you have two types of dilations. You have a reduction and you have an enlargement. Those are your two types of dilations. With a reduction, obviously you guys have pretty good vocabulary. Reduction means what? Reduce it. You're getting smaller, right? So this one is getting smaller. Okay. In getting smaller, and this question kind of confused the last class. What type of fraction makes something smaller? Thanks, Eric. Yeah, what type of fraction? Okay, a negative, I agree with you, but can you have negative length? No, so that's not going to work. Now, with an improper fraction, let's think about this. An improper fraction, that'd be improper, right? What is that as a mixed number? 1 1/2. If I use a scale factor of 1 1/2, I'm using one whole of it and then another half, right? Is this getting smaller or bigger? This is actually getting bigger. So, just some regular fraction, right? Like 2/3. 1/2. 1/3. Wouldn't that make things smaller? Yeah. So my scale factor has to be where from 1? Less, right? Less than 1. My scale factor has to be less than 1. Because if it's less than 1, I'm making it smaller. If it's equal to 1, it stays the same. Right? My scale factor, if I just have 1. Right. You're never going to have a negative scale factor, though. So, because our scale factors have to be between 0 and 1 or greater than 1. We learned that a while back. Yeah, you'll never have a scale factor of 0 because then it just disappears. We don't have any disappearing shapes around here. Okay, so an example would be like 1/2, right? That would make something smaller. It'd be half the size, right? 1/3, it'd be 1/3 of the size. 2/3. Those would all make my shape smaller, correct? Okay. So with an enlargement, we know enlargement means what? Gets bigger, so it's getting bigger. What am I going to fill in for this line? The scale factor has to be greater than 1. Now, does that mean that it's going to be a whole number? Does that mean it's going to be an even 2, an even 3, an even 4, and so on? No. What's an example in a fraction form of a scale factor which is greater than 1? 3 halves is greater than 1. 5 halves. 7. That'd be 7 over 1, right? I don't have anything today, Braden. We'll probably have something a little later this week. We won't be in here tomorrow, so you don't need to come tomorrow. But then Thursday, I'll have copies for you to make. Okay? Okay, so those would all be scale factors which are larger than 1, which would make things bigger, right? Okay. Now, what I do want to be very careful of, when you're doing dilations, you're always going to have a center point. Just like when we did rotations, you got to have a point that you're starting with, and you're basing everything off of. Okay, so if it's that point, and my dilation looks something like this, okay, maybe this is A, B, C, and this is A prime, B prime, C prime. Without any numbers, can I tell whether this is a reduction or an enlargement? Yes, I should be able to from previous information that we've learned. McKenna, how do I know? The prime comes first or second? Second. So is this a reduction or an enlargement? This is an enlargement. I started here with triangle ABC, and I went over here to triangle A prime, B prime, C prime. That tells me I started here, got here, so that's an enlargement. Which one's the pre-image? ABC, the small one. Which one's the image? A prime, B prime, C prime. Okay. Now, you should have already been able to do that. Now, what if I do this, and I ask you, what's the scale factor? It's a trick question. Jacob? Okay, you're really, really close with that. Jacob says 2 over 5. Now, first of all, I heard a lot of 3 over 2s, right? Can somebody explain to me why that does not work before I go on to Jacob's? Looking at this, my 2 is from my center point to my vertex, right? 3 is not from my center point to my vertex, is it? 3 is just from here to here. That would be like on those problems that we had last week, or just the other day actually. You have x, and you have 12, and you have 14, and you have 20. Okay, can I do 14 over 12 equals 20 over x? No, because 20 is that whole side, isn't it? X is not. Okay, that's the same thing that we're trying to do over here. 2 is the whole side, isn't it? Is 3? No. Okay, so instead of a 3, or let's just say that it's not going to work. Okay, so now I come down to what Jacob was telling me, and he used 5, which is good, right? The only problem here is what? Go ahead, Austin. He has it flipped because this would be a reduction, right? Okay, so Jacob had his numbers right. We just need to flip what Jacob told us. My scale factor should be 5 halves because it is an enlargement. So it does have to be greater than 1, correct? Yep. Good with that, Jacob? You probably noticed that right after I started talking about it, huh?
Yeah.
Okay. Okay, so just be careful with that. We know that if you reduce or do a reduction, it has to be less than 1. And we know that if you do an enlargement, it has to be greater than 1. Okay. So let's take a look here. Example 1. I don't really know what's going on. Is it still videoing? I think the battery's dying. I haven't charged it for a couple weeks. Okay, so let's see if we can get through this with that. Example. Yeah, it says no, we don't have enough power. Okay. I'll just scoot over here. Example 1 says, identify the dilation and find its scale factor. Okay, on that, okay, part A. Gavin, part A, is that a reduction or an enlargement?
It's a reduction.
It's a reduction because the P prime is smaller, right? Okay. And since it's a reduction, Tamaya, what is the scale factor? 2/3. Good. And part B, Lainey, reduction or enlargement? Enlargement, because the one with P prime is larger, right? And Lainey, go ahead and give us the scale factor as well. 2. 2 to 1 or just 2, right? Okay. Alright. We only have one more example, okay, but I got a couple things that we need to talk about with it. So it's going to be on graph paper. If you want some graph paper, use that manila colored stuff in the back, please. Alright, so they give us 4 points. They give us 2, 2 for point A, 6, 2 for point B, 6, 4 for point C, and 2, 4 for point D. Okay, so we have a rectangle. Okay, off to the side here, I'm going to do our work. They also want us to apply a scale factor of 1/2. That's example 2. Apply a scale factor of 1/2. Well, immediately I should know that that's going to be a what? A reduction, right? Everybody agree with that? Wonder if the volume still works on this. Hope it's still recording my voice. Hey, it's going to be a reduction though, right? Okay, so I take, and I need to multiply each of these by 1/2. Well, 1/2 of 2 is 1. 1/2 of 2 is 1. 1/2 of 6. 1/2 of 2. 1/2 of 6. 1/2 of 4. 1/2 of 2. Oops, not 2. 1/2 of 4. Plot my points. 1, 1. 3, 1. 3, 2. 1, 2. And I have my reduction. If I wanted to go ahead and draw these in here, they should meet both those same vertices. Yeah, just make sure your coordinates are somewhere. Okay. All right. And then let's change this up a little bit. Does everybody have that? Okay, what if instead of this we have I'm just going to do a triangle. It's -2, 1, -6, 0, and -1, -1. Okay, but now they want to apply a scale factor of 3/2. Okay. On the previous one, didn't I multiply 1/2 times everything? Okay, so are you still going to multiply? Yeah, except now you're multiplying 3/2, right? Which is going to be a little bit different. Okay, you just have to be careful. Okay, what is -2 times 3/2? -6/2, which is -3. 1 times 3/2 is 3/2. -2, or excuse me, -6 times 3/2 is -9. 0. -1 times +3/2. -3/2. -1 times +3/2 is -3/2. Okay, so you're actually multiplying every time, correct? Just so we're clear on that. Oh, but it's not recording my voice anymore. It's dead now. Is it still recording?
Yeah.
Okay. It should be. It's just on my phone. Okay, so I have -3, +3/2. I have -9, 0. And I have -3/2, -3/2. And obviously that is an enlargement, right? Should it have been? Yes, with a scale factor of 3/2 it should have been.
So what are the lines you drew, like the black ones you drew last time?
That would just be your lines to your center point. So like if I draw the lines to the outside vertices, they should touch. So like this is A, this is A prime, this is C, this would be C prime. Your outermost vertices are going to touch those lines if you draw them. And it should line up. Okay. Questions on any of that? That's all it really is for this lesson. Hey, you're still using proportions if you have to solve, because we have scale factors, right? Okay, so anything with scale factors, you can still use proportions to solve. And there's our assignment for tomorrow. Pay close attention to this, please. You have 4 graphs, so please use the smaller sheets of graph paper. Just use 2 of them. Also, I had some confusion. I'm not sure why. Do you draw the original? Yes. With the original drawn. Draw the original diagram, please.